In this video, we'll run through some additional examples of solving quadratic equations using the quadratic formula. So in this case, we want to solve the equation x squared equals 36 minus 12x. So this one is not in standard form, so I'm going to get it in standard form first there. So looks like I hate to have a negative coefficient on my squared term, so I'm going to add 12x and subtract 36 from both sides. So on the left we would have x squared plus 12x minus 36 equals 36 minus 12x plus 12x minus 36. So on the right hand side, everything would cancel out to 0, and we would have the equation x squared plus 12x minus 36 equals 0. And now we can use the quadratic formula. So we need to identify our a, b, and c. So a is 1, b is 12, and c is negative 36. So let's plug that into the quadratic formula. So again, quadratic formula, let's write it down. X equals negative b plus or minus square root b squared minus 4ac all over 2a. So now let's plug in our values and work this out for our problem. So we would have negative 12 plus or minus the square root of 12 squared minus 4 times 1 times negative 36 all over 2a, so 2 times 1. So keep going, x equals negative 12 plus or minus, well, 12 squared is 144. And notice with this subtraction and this minus, we've got two negatives. That's going to change that sign to a plus. And then 4 times 1 is 4 times 36 is 144 all over 2. 144 plus 144 is 288. So we have negative 12 plus or minus the square root of 288 all over 2. Alright, so now let's see if we can simplify the square root of 288. I'm going to do that over here. So we've got the square root of 288. Well, I know two 144s make up 288, so I'm going to start that with my factor tree 2 times 144. And hopefully you realize we could stop there and not, we've simplified enough square roots so we don't really have to keep going. And what gives it away there is I already know that 12 squared gives me 144. So this problem kind of helps me out there. So 144 is a perfect square. Hopefully we're getting to the point that we start recognizing some of our perfect squares. So 144 square root of times our leftover square root of 2. Square root of 144 is 12. So we've got 12 times square root of 2. So I'm going to replace the square root of 288 with 12 square root of 2. So we've got x equals negative 12 plus or minus 12 square root of 2 all over 2. And then we want to see if this fraction reduces. So if all of our coefficients, so our negative b, the negative 12, the number we brought outside the radical, and the number in the denominator, if they all have a common factor, we can simplify this. And they're all divisible by 2, in fact. So in fact, I'm just going to split this up into negative 12 over 2 plus or minus 12 square root of 2 all over 2. And then Negative 12 divided by 2 is negative 6, plus or minus 12 divided by 2 is 6, square root of 2. So we have two solutions there. So our solution set is the set that includes negative 6 plus 6 square root of 2 and negative 6 minus 6 square root of 2. Again, notice there that our two solutions still involve square roots, in fact square root of 2, and they're conjugates of one another, so they differ only with this middle sign. This one has, first one has a plus, second one has a minus. So our solution are conjugates. So that's something we talked about in the square root property video there. If you have solutions that still involve radicals or involve the imaginary unit, there will be conjugates of one another in a quadratic equation. All right, so in the next example, you may want to pause the video and try this one on your own. All right, so this one is in standard form, so let's go ahead and identify our A, B, and C. A is equal to 10, B is 2, and C is 1. So let's write down the quadratic formula and then plug our numbers in. So x equals negative b plus or minus square root of b squared minus 4ac all over 2a. So plugging in our values, we would have x equals negative 2 plus or minus the square root of 2 squared minus 4 times 10 times 1 all over 2 times 10. So let's carry out that arithmetic. So that would be x equals negative 2 plus or minus the square root of, well, 2 squared is 4 minus 4 times 10 is 40 times 1 is still 40 all over 20. 4 minus 40 is negative 36. So we've got negative 2 plus or minus the square root of negative 36 all over 20. Square root of negative 36 is a complex number. It is equal to 6i, because square root of 36 is 6, and then square root of negative 1 is the imaginary unit. So negative 2 plus or minus 6i all over 20. When our solution involves the imaginary unit, we split that up into what we call the real number part, the part without the imaginary unit, and the complex number part, the part with the imaginary unit. So we would split that up into negative 2 over 20 plus or minus 6 over 20i. And then both those fractions will reduce by 2. So 2 over 20 reduces to 1 over 10. So 1 negative 1/10 plus or minus. 6 over 20 reduces by 2 to 3/10. So again, we have two solutions. We have two complex solutions because our discriminant, negative 36, it's obviously negative. So our two solutions are negative 1/10 plus 3/10 I and negative 1/10 minus 3/10 I. So two complex solutions to this one. All right, one last example here. Again, you may want to pause the video, try this one on your own. All right, so let's see here. First of all, this one is not in standard form, so let's get this one in standard form by adding 3 to both sides. So we would have 5x squared plus 8x plus 3 equals negative 3 plus 3. The negative 3 plus 3 will cancel on the right, so we'll have 0 on one side, and we have the equation 5x squared plus 8x plus 3 equals 0. So now let's identify our A, B, and C. So A is 5, B is 8, and C is 3. Our quadratic formula again, x equals negative b plus or minus square root of b squared minus 4ac all over 2a. And now let's plug in our values. So x equals negative 8 plus or minus the square root of 8 squared minus 4 times 5 times 3 all over 2 times 5. So let's clean that up a little bit. So x equals negative 8 plus or minus the square root of, well, 8 squared is 64 minus 4 times 5 is 20 times 3 is 60 all over 2 times 5, which is 10. So 64 minus 60 is 4. So we've got x equals negative 8 plus or minus the square root of 4 all over 10. And then we can continue cleaning that up because square root of 4 is just 2. So we've got negative 8 plus or minus 2 all over 10. Now please be careful there. The square root of 4 is 2, not square root of 2. So do not make the mistake of leaving a radical around the 2. It's square root of 4 is just the real number 2. It is not equal to the square root of 2. So let's see. So we can split that up into two separate answers there. So we've got negative 8 plus 2 over 10 and negative 8 minus 2 over 10. And those we can actually reduce down. Negative 8 plus 2 is negative 6 over 10, which if we reduce that fraction by 2, we would end up with negative 3/5. Negative 8 minus 2 is negative 10, all divided by 10, which is negative 1. So we have two real number solutions there. So our solution set would be the set that includes negative 3/5 and negative 1. All right, so that concludes our video lectures on the quadratic formula.